All right, friends. Welcome to one more session. And today in this session, we're gonna learn what is correlation and how you're supposed to use correlation for your statistical inferences. Correlation is one of the very prime component for data sciences to understand whether there is an influence of one event on another. This is used not only in engineering, also in all domains of sciences and sociology, where we wanted to find out any event and how that particular event is actually getting motivated or driven or affected by some other event. There are multiple questions which can be addressed if I learn correlation. So stay tuned and enjoy the session. All right, let us talk about correlation. Now, this particular concept, correlation, is very significant in terms of making one assumption or making any statistical decision. The first thing gonna be the correlation. If I have to find out what is correlation and how does a correlation works, we have to primarily take a look into few couple of concepts. So let's see basically what is a correlation and how we're supposed to understand correlation. Assume that we have two variables, one is x and another variable is y. Now I have to understand how x is relatable to y. Maybe y is just a function of x, where the moment x increases, y also increases to the positive direction. That means for every positive value of x, I get one positive value of y. It can also be possible that there is no correlation between x and y. The values are completely independent and probably they don't have any significant relation among themselves. This is also possible that for every positive value of x, we get one negative value of y. If the function is defined something like this, y is equal to minus fx. That means for every value of x, I'll get a negative value of y. Now all these can be considered as my different components for understanding the correlation between two. To understand correlation or how these components are actually interrelated, we have three measures, or primarily one measure, one variable, and based on that variable, we will be able to identify what is the relation between two set of values or two variables in short. The measure is called correlation coefficient. What is correlation coefficient? Correlation coefficient in short will define what is the relation between two set of values or two variables in short. Now, the correlation coefficient can return three significant outcomes, or all the values of correlation coefficient will range between -1 to +1, and it can also be 0. So either I'll get some values which is between -1 to +1, and also I can get some values as 0. Now what does this mean? If I get a result of a correlation coefficient as -1, that means I'll understand the values are correlatable, but they don't have a significant, but they have a negative correlation. So it's a minus correlation or a negative correlation. If I get the values greater than 0 and moving towards +1, then I'll understand there is a positive correlation. Whereas if at all the value is absolutely 0, then I'll understand there is no correlation between those elements, right? There are multiple other ways or multiple other factors which also to be considered to understand how a correlation works, and there are multiple methods which we actually going to talk about in the R code. But before that, what is the correlation calculation formula or correlation coefficient calculation formula? I assume core coefficient as the name of the variable, which is the correlation coefficient variable. And for that, the standard formula goes as something like this. Summation of x of I minus x bar. What is x of I? X of I can be any variable, any element in the variable x. And what is x bar? X bar is nothing but the mean of that particular correlation or particular variable set, which will be again multiplied by y of I minus y bar, which is once again any element or rather all the elements from the second variable y minus the mean of the variable y, which should be divided by another set of formula, another set of component, which will say the root of, again, summation of xi minus x bar whole square multiplied by summation of yi minus y bar square. So this is basically the formula to identify how to define correlation. Let us quickly take one manual example here, and which will help us to realize that how basically these things works. Assume that I have two set of variables now. One is x variable and another one gonna be my y variable. For each of these variables or each of this collection, we will be having 5 values. For example, the values are 1, 2, 3, 4, and 5. Similarly, for x, I do have some values which are -10, -20, -30, 40, +40, and +50 as a matter of fact. Now, first thing first, I should be calculating the x bar and y bar, which are the means. So for my case, in this x bar, I will be getting 15 divided by 5, which will become 3. And in this case, I'll be getting some y bar. For instance, that will become 30, and which is divisible by 5. So I'll be getting it as 6, something like that. I'm not getting into the detailed calculation of that, but the example is something like this. I'll be calculating the mean for x and the mean for y. All right. Moving back to the actual formula what we had. Now for correlation coefficients, I have to multiply all these components here. First, let us see one simple example of the numerator, then we'll see an example of the denominator as well. So let's see how does that goes. So the first component I'm gonna say will look like this: 1 minus 3 multiplied by, this is first component, multiplied by -10 multiplied by -6. And then I'll go to the second element, I'll say plus, because there is a summation symbol in the formula. So I'll say plus, and I'll say 2 minus 3 multiplied by -20 minus 6. I'll say plus, and this formulation will keep on going, and it will repeat for all the 5 elements of x as well as all the 5 elements of y. Now, for the denominator part, we're going to have a root, and inside the root, we're going to have the summation separately. So we're going to have, first of all, 1 minus 3 square multiplied by minus 10 minus 6 square, and then I'll keep on doing the addition for all the other elements. Maybe this will technically result in 0.7. If I get a value which is 0.7, then based on our analogy, where if the value is in between -1 to 0, I say there is a negative correlation. If the value is in between 0 to +1, I'll say there is a positive correlation. And if at all the value is exactly staying at 0, I'll say there is no correlation. Coming back to this situation, we are approximately, or we are assuming that the value is 0.7. That means here we can conclude, or we can infer there is a positive correlation. So this is how the situation should actually move forward. All right, so now let us see one quick example. How do you do this correlation and how to get those values ready? So for this purpose, once again, we'll be taking two specific collection. The first collection, once again, as per our example, I'll be calling it as X. And inside that, I'll have the values as 1, 2, 3, 4, and 5. For the second collection, Y, I'm going to have some similar set of values where, first of all, let me take some positive values here, 10, 20, 30, 40, and 50. And then finally, we wanted to have the correlation coefficient generated. But before that, let me execute these two lines and get the variables ready. Now to do this, the correlation calculations in case of these two sets, X and Y, we can have multiple methods or multiple strategies of doing that. The first strategy, the very popular one, is called the Pearson strategy. The second one is called Kendall strategy. And the third one is called Spearman strategy. So let's see how we're going to apply those strategies. It's not necessary that we're going to apply all the specific methods or all the specific strategies at the same point of time, but this is fine if you wanted to apply also. My first case, I'll be using the method called COR, which is my method for calculating the correlation. And my first two elements will be the two sets in between which I wanted to figure out what is the correlation, and then I will be mentioning the method. So using the phrase method. Now inside that, I can start with the first one, which is kind of popular, and I say Pearson for this purpose. So I'm using a Pearson method to find out the correlation. Now I see the correlation is 1. The value of the correlation coefficient is 1. The reason behind, from the data, it is very obvious to see that all the values for every positive value of X, we are getting one positive value of Y, which defines it's a strong correlation and it's a strong positive correlation. What happens if I go ahead and change these variables, all these variables into negative? So what happens this time? I'll be loading this to collections once again, and this time I'll be executing the same line number 3, the correlation formula. This time we can see that it's the correlation coefficient value is -1. That means once again there is a very strong correlation. However, the correlation is a negative correlation because for every positive value of X, we are getting one negative value of Y. What happens once again if I just randomly change two variables to positive? That means for all these variables, all the positive values of X or all the values for X, we are not getting all the negative values of y. Sometimes we are getting a negative value and sometimes we are getting a positive value. Let's see what happens this time if I calculate the correlation coefficient. Now this time the correlation coefficient is saying 0.42, which is greater than 0. That means there is a positive correlation, and it is nearly 42% of positive correlation is available here. I can always mention that one in a opposite direction. I can also mention 1 minus this correlation variable, something like this, which will tell me what is the opposite of that particular correlation. So that says, having said that, that is 57% of the data are negatively correlated. Okay, right. One more example we can find out here. Let us see, we don't have any correlation now. For every value of x, we get some random value of y. It's 4:30. Some random values of y. So let us go ahead and get it executed now, these two variables. So my collections x and y are ready. Now I'll be executing my Pearson variable. Still, there is a correlation found, and this correlation is actually in a positive side, which is 0.7, which is good, and that is towards 1, and that is positive. That means this variable is right now having a positive correlation. What happens once again if I change all these values to a specific value like 44? For all the 5 variables. Now my data is loaded, both the collections are loaded, and this time let me execute that. Now this time they are saying the standard deviation is 0 for the second one, because there is no variation in the data, and it will be very hard to tell whether there is a correlation exists or not. If I have a complete set of random values, I can always go ahead and say, yes, there is no correlation possible. Now, this talks about the Pearson method. I can also do the same thing with my alternate method, which is called Kendall method. So I'll mention in place of the method, I'll mention Kendall, and let us get executed, and I'll be getting some sort of a correlation value available for that. What are the purposes of this different mechanism? Because they utilize different algorithm to find out. But as once again, the Pearson method is most popularly used. Now the last one will be using the Sparman method. For the Sparman method also, we'll be getting the correlation where they're saying there is almost a 50% correlation among these two set of data. So this is the standard method once again, how to collaborate and how to figure out whether there is a correlation between two elements or not. We can get a lot of statistical conclusion only by these parameters. I can have x and y, and I can have the method name mentioned here or the strategy name mentioned here, by which I will be using the correlation calculation to extract the correlation coefficient value. All right, guys, I hope you learned what is correlation and how to use correlation using R programming. The very fundamental and primary important takeaway supposed to be from this session to understand how to define correlation with the help of correlation coefficient. And I hope you remember there are 3 variations or 3 rangeal variations of correlation coefficient. One is -1 to 0, at 0, or 0 to +1. And I hope you also remembered how to understand those 3 different ranges to make a conclusion out of the correlation. See you once again in the next video. Till that time, stay safe, stay tuned, and enjoy learning.